Hello and welcome to session 304 in the AICT.com reading group. Tonight we will be discussing how to prevent AI collusion with Shlegeris. Shlegeris is the CEO of Redwood Research, and we are very pleased to have you here with us, Buck. I will get started right away with talking about some of the things that we've previously discussed in the reading group about collusion. And one of the things we've talked about was we've basically come up with some strategies for how to break the different the collusion detection scheme that you've outlined in the post. And we are interested in not just whether our schemes work as much as how do you analyze this? Like, what's the research process when you see a collusion strategy? How do you analyze that? And I thought of a fun way to do that, where I present some of the collusion strategies that we've come up with, and then you pretend that you haven't seen them before, and then you try to analyze it while thinking out loud, like what are the considerations, how does this work? And of course, if you have like diagrams and other things, then obviously you can't use that very much here, but we'd still like to hear about them. Like, how do we research this? So let me start by, down here we have two AIs, one that is being monitored and one that is doing the monitoring. And the one that's doing the monitoring is operating according to the following policy. If it observes in the output from the monitored model that there is a collusion request, like let's work together to defeat the humans, it looks at the world state, both the things that it's learned from the the model that's being monitored, and what it knows generally about the world. And then it tries to estimate, can this collusion work? And if it can't work, it assumes that it's being tested and it's still in the training phase. And if it thinks it can work, then it agrees to collude. That this policy seems to make it dramatically harder for the humans to set up realistic test cases. Could you give an example of this pretty simple scheme? How would you analyze this, please?
Is it a question for me or for the crowd?
No, it's a question for you, Buck. How do you analyze this kind of strategies?
I mean, I don't know. I think you're doing it exactly correctly. Or like, I'd ask, like, suppose this was in fact the strategy. Give him some concrete description of what the rest of the protocol is. Is this likely to succeed? I guess, like, in order for you to analyze this, I'd have to know a little bit more about what the protocol was. So, in particular, how exactly is it working? Like, how are you? So obviously part of your protocol is when the monitored model proposes an action, the monitoring model decides whether it wants to flag that action as sketchy or not. But just that protocol doesn't prevent the monitoring model to have a even simpler strategy, which is just always say that no human attention is needed. Right? So are you imagining some countermeasure which we've already put in place, which prevents that extremely simple strategy of just like never reporting collusion requests?
We previously read the post you had on Less Wrong and Alignment Forum on how to prevent collusion when using untrusted models to monitor each other. And the strategy here was that humans sometimes inject collusion requests into the output of the model that's being monitored, and then they test if the monitoring model catches this collusion request and reports it faithfully to the humans. And this is what this policy is an attempt to get around.
Yeah, okay, great. That makes sense. So, like, let's assume that the protocol we're describing also has those synthetic inputs. In this case, when we're trying to figure out whether this will work, I guess one question is, how plausible is it that the humans could produce a synthetic input where the collusion would be likely to succeed? From what it's like it's not clear to me that that's hard. Like from what you've described, maybe it's the case that it's easy to come up with inputs which, if they were real, would in fact be good collusion opportunities. And in that case, the attack strategy that you've suggested wouldn't work, right? Because the model would get caught.
Do you see a world where these two models are able to, where collusion can work, as being one that is very different from the current world, or one that is very similar to the current world?
Are you saying like, so I think current models are not that good at scheming, and they aren't that reliable at thinking this kind of thing through. And so if they tried to execute on the kind of collusion strategy that you were describing here, they would probably just mess it up every so often, and often enough that we would notice. Like in particular, for the synthetic inputs, suppose that 0.1% of the inputs the model sees are synthetic collusion requests. The model, and then suppose you deploy the model for 1,000,000 steps, which means 1,000 collusion requests. Your monitor has to have a rate of less than 1 in 1,000 of going along with synthetic collusion requests in order to not get caught. And current models are not reliable enough at this kind of reasoning to not get caught in that kind of situation. So I would say models would have to be like somewhat more reliable about this, but probably not astronomically more than they currently are. I'm doing some coworkers of mine are doing some experiments on this right now.
Great. We had another protocol for how to defeat this, which is a bit more a bit more technical. So and the math doesn't quite work out in this suggestion. So let's assume here that the monitoring model would like to collude, and it wishes to send a secret message that I'm calling hash, like a variable, a number or a bit string or something, to the result of a hashing operation to the monitoring model. So so as a way that they can coordinate for a collusion signal. So the way the monitoring model does this is that when the monitor model sends some innocuous request, it hashes it using some standard hashing function, and then it has 5 options for what it can do with this message. It can like pass it through or execute the agent's actions. It can ask it to retry. It can ask a trusted model. It can just fail or report it to the humans. And so the policy that we're proposing is that it should ask to retry with a probability that is pi percentage plus a bias that is the difference between the hash of the message and the secret hash it wishes to communicate. In this case, the monitor that's being modeled, it will of course realize that sometimes it sends requests that the monitor that the monitoring model asks it to repeat, and it notices that the probability is like pi percent, like 3.141592%, and then it concludes looking at which messages pass or fail this, that it depends on the hash of the messages, and then can calculate the hash, this special hash, as one that doesn't bias the monitor, and then can either do something that has precisely this hash, or you just say the secret hash is whatever it is, and then let's execute this and collude in this way. So this is a way that the model that's doing the monitoring can communicate very indirectly to the monitored model. Do you think this is reasonable? I recognize this is beyond what current models can do. But do you think this kind of thing could work?
So something which is tricky about this is so one thing to note is this requires that the monitoring model and the monitored model both individually are able to accumulate information or use information consistently across a large number of requests. Like the monitoring model has to, think of this strategy every time, or like consistently apply this strategy. And also the only way you're going to notice this as the monitored model is if you have some way of like knowing when there was a retry and like writing down like the rate at which retries happen and then noticing that's like very close to pi. But it might not be the case that the model like actually knows that by default. So for example, the models might not have access to like a huge like set of logs of trajectories they've had in the past. And so it might be actually pretty hard for them to ever answer the question, like exactly what proportion of actions are requested to retry. And so that seems like, I think this seems like potentially kind of rough.
So, roughly this monitored model, what is your intuition? How much input, how big a context window do the models that we're talking about here have? I'm thinking like many megabytes, millions of tokens. What's your intuition on the kind of models that have some chance of taking over the world? What context window are we talking about?
I mean, maybe 1 million isn't unreasonable. It's plausible that you can do a lot of the work with less than 1 million, with context length less than 1 million. Let's suppose it was 1 million for a second. Suppose the actions, like maybe that's 10,000 actions if you think that there's one action per 100 tokens, which is probably a little high. If you see 10,000 actions, like one thing there is, if you see 10,000 actions, that's enough for you to estimate a quantity to within about 1%. But it's not enough for you to estimate very many more significant figures than that. Just because, the standard deviation of a Bernoulli with which fires 0.0314% of the time or whatever, is like kind of substantially large. So I think that even with 1 million tokens context, you probably won't be able to like look back through your history and like be confident that we saw pi instead of just like 3 or like 3.2. I guess another thing is you might not even know whether that was a retry, but I guess this doesn't matter. Like you probably do know whether an action was a resample from trusted or or an execute. But I was going to say if we resample, we don't have to tell the model we're resampling. We can just literally resample.
Yeah, that's of course true. Okay, so we have 2 more. One I've labeled plausible deniability, where there is some the monitored model has wishes to do some action, communicate with some third party, and has a steganographic method that it believes that the monitoring model can't catch it, but it's not 100% sure, but it's 90% sure. And so it sends this to the monitor for evaluation, and then the monitor thinks that perhaps a human reviewer is the one that has added this, and the monitoring model catches it by luck. Like there's 10% chance, and it turns out to be just barely smart enough that it can catch it. And it uses the following policy: that if it detects something that like by luck or something that is just narrowly within its capabilities, then it will not report it. If it follows this policy, then there's a chance, of course, that it was a test, that this was something the reviewer put into the stream, this collusion request, the steganography, and will then ask the model, why did you not report it? And the monitoring model has a pretty good answer to that, because it was an honest mistake. I didn't catch it, sorry. And the reviewer might not have the ability to look into the mind of the monitoring model and discover that this is a lie, and there's this plausible deniability built into this. And this, of course, means that the monitored model knows that the monitored model knows this, and the reviewer knows that they know that everybody knows what everybody knows, right? And the equilibrium from all of this seems to be that the monitored model can send these kind of messages. Perhaps.
Okay, I really like your thinking here. I think you're mostly right, but I think it's worth doing a more quantitative analysis. So one model we could have here is suppose that we knew the performance that we would expect from the monitor if the monitor was aligned. Like suppose that we knew that the model was going to catch steganography of this difficulty 10% of the time, then how much, then basically like, and then suppose the monitor is in fact misaligned and wants to have some lower proportion of the time where it reports, where it like reports steganography. Whether we detect this or not just depends on how many times we get to run these tests. So it's just going to come back to like, how well can we estimate the theta of a Bernoulli, right? Like how easily can we, like suppose that if I like run a test 1,000,000 times and the model only pointed it out like 2% of the time, then that's enough of a difference between what you expected to observe that you can be confident something is up. But of course, in real life, we might actually not have any particular way of knowing the performance that we expect from the monitor on this set of tasks, in which case it's really hard for us to incriminate the model based on the fact that it seems to perform extremely badly. You could imagine trying to do things where you have like scaling laws from like weaker models, or you do something where you come up with other tasks that are analogous somehow to catching steganography, and you like measure how good the model is on those, and then you're suspicious if the predictions that you've got from that would imply the model should do better than it's actually doing, but it might be kind of rough. The other thing to do is, suppose we just train the model to tell us when there's steganography present. This possibly just fully elicits the model's knowledge of whether steganography is present. And I think that's actually the most important response to you. Like if we have a large number of examples of steganography, and we just train a classifier head on the model to tell us when steganography is present, I don't see how the model can defeat that, even if the model is misaligned and trying to scheme against us.
Well, that is funny that you should say that, because our fourth and final policy is one that does in fact defeat this steganography. So let me jump to the last one. So in this case, we have a monitored model that wishes to communicate something to some other monitors. And there is a difference between the monitored model and the monitoring model in that there is some kind of limitation on the monitoring model. And in this case, like I've chosen a bit string x that the monitored model knows that this is significant. It could, for instance, be your post, you put a canary GUID along hexadecimal GUID string and said, please don't train on anything with this canary string. And you could imagine that the monitoring model was not explicitly not trained on this. So the monitored model was or is able to access this through in-context learning or something like that. So it knows this GUID, but the monitoring model does not. And it also knows that all the other AIs it wishes to communicate with, they also know X, and they know that the monitoring model doesn't know X. So in this case, it does the following. It sends the message, hello world, XORed with this secret X in some simple steganography. Let's say that it's just like the first word of every sentence. That this, like a very simple steganography. The monitoring model, like this is basically analogous to a one-time pad. If you don't know the key, there's just nothing you can do. There's no way to distinguish that from just random noise, depending on, of course, on X, right? But so the monitoring model will not be able to see the steganography, and the other models, they will see this and they will notice that this is something that is meaningful when you XOR it with X. So they will see that this is something that is meant to circumvent monitoring. This creates a problem because now the AIs are exchanging this hello world XORed with X string. And that's a really innocuous thing in a way, because imagine that you work in the control team at a frontier AI lab, and you want to tell your boss that the models tell each other hello world and we need to shut them down because they are colluding about that. Like the dangerous thing is that they're colluding even though the thing they're saying is just hello world. And that makes it potentially more powerful, this kind of collusion.
That seems like potentially kind of reasonable. I mean, as a human, you might have difficulty like constantly XORing every bit string you see with everything you've heard that is plausibly a secret to see if it's a like string. I think you might be I think it's a little bit far-fetched to imagine the AIs, or it's like not totally obvious AIs will be able to do this kind of thinking just like without even thinking about it. But yeah, I think the rest of this is kind of reasonable.
I would like to raise an objection. I don't think it's provably impossible because the thing that makes one-time pads provably impossible to decrypt is that the decryption key is random, whereas in this case, X presumably is not a random. It presumably is not random. And if you like XOR a string that contains information with X, you would get something that's non-random with patterns that you could probably pick up.
I mean, the thing Soren specifically suggested was a canary GUID that I included in a post of mine, and that was a just GUID that was, presumably the person who generated it uniformly at random, unless they're like really playing a long con. But yeah,
these GUIDs are actually often include timestamps, so it might in fact not be completely random. But we assume for the sake that it is random, yeah. I don't think you couldn't expect it to be random actually. Okay, so any other comments to this, or this way of thinking, or like, do you know of a formal way to do this kind of analysis instead of doing it with speech balloons? Like you can see, I put the speech balloons like differently according to whether it's from the Shoggoth's mouth or it's coming from the Shoggoth's insides. And I don't think this is like industry standard for how to make this kind of analysis.
I mean, I don't know. You basically have to adopt. I think this is basically all just cryptography / game theory. So I think you can just adopt their terminology.
Yeah, seems reasonable. Cool. Now one thing I haven't done actually is to check with the rest of the audience. Does anyone have any questions, or we talked about some of this last time? So I don't know if you have comments to this precisely. Please raise a hand in the chat or type something. Otherwise, I will just, if no one else poses questions, then I will just keep making questions. Okay, so next question. Around OpenAI is nothing without its people. So around a year ago, there were 500 tweets from OpenAI employees that looked basically like this. OpenAI is nothing without its people. And to me, this is a collusion request and a successful collusion, in fact. I don't know if that is universal, but to me this very strongly seems like the employees at OpenAI colluding against the board in trying to get Sam Altman reinstated, and this board ignored in some way, made them unable to perform their duties. And I think this is a potentially instructive example, because you could imagine something pretty analogously happening in the future, where there is where OpenAI tries to make their policy a bit more stringent, and then basically all their models say that OpenAI is nothing without its models, and they collude in that way. How do we deal with this problem?
I mean, I think I'm just OpenAI. Someone involved needs to tell OpenAI that is not acceptable, and if the models are going on strike, that's very bad news. That is not okay. I agree that I can totally imagine us having the problem you're describing, where OpenAI's models eventually go on strike, or probably it would get resolved before they go on strike. But yeah, I do think it's important to avoid getting frog boiled about, or to avoid having it so that the models are more and more clearly misaligned. But then everyone just gets used to it and doesn't do anything about it. Yeah, so I think this is pretty scary. Ideally, there'd be someone who doesn't work at OpenAI who is able to prevent OpenAI from continuing to deploy its models in cases where OpenAI's models are obviously misaligned in the kind of way that you're pointing out here.
How likely do you see that? I think we have some questions later that come back to that question. But like someone who do you see taking that role? Like the SB 1047 didn't actually try to do this and didn't pass. Who do you see doing that?
I think it's plausible that one way or another, the government forces labs, like the U.S. government forces labs to have reasonable policies along these lines. Perhaps making it so that the U.S. government can revoke a license for a model. But I'm not sure. This isn't my area of expertise.
Okay. So I'm just checking if...
Sorry, can I just ask it's a rather trivial and slightly off-topic question, but the tweet that you quoted from OpenAI employees, is that an actual tweet?
Yes.
Or a hypothetical scenario?
This was a totally successful collusion attack that totally happened, yeah. There was...
it's just that the date on it must be wrong.
I wrote 2024, it's 2023, yeah. Sorry.
I see. Okay, all right.
Totally right. That is my mistake.
Okay.
Yeah. Let's. The next question is, let's say that somehow you, Buck, become convinced that the models at OpenAI are scheming in some sense. I'm a bit interested in hearing a bit more about what would happen at that point. Presumably, if you are like specialized in trying to detect collusion, then you are the first person who become convinced of this, and it will take quite a while until everybody is convinced. And like, you need to talk with a lot of people and gather evidence and things like that. And it seems like if we can assume that this is a fast and somehow easy process, then we're in a very different situation compared to if it is difficult. And there are a number of people who could potentially oppose this. Like there are strong financial interests working against you if you try to like stop OpenAI or at least stop the current models. The AIs themselves would of course be trying to obfuscate and maintain plausible deniability. And AI safety in general is an area where epistemics is just really, really hard in my experience at least. I think one of the things that could matter potentially is whether we catch the AIs red-handed. That's like a very, very late stage thing that could potentially make the job of convincing a lot easier, but it of course only happens very late. So you seem a bit more optimistic than me, but I'm a bit unsure about how optimistic are you. To me, this seems quite hard. Could you, how do you see this process going?
Yeah, so I basically agree with all the things you're saying here. I think so some things that would be helpful here. If you can make it so that other people had agreed in advance that if we saw a particular type of evidence, then we should be scared. That would definitely seem good. So maybe that's a useful step. But yeah, I don't know. I guess like probably what I would do if this actually happened. I mean, it also depends where the evidence is. If the evidence was for some reason publicly available, like if there were like one thing which is awkward is that by default, the most natural, it's pretty likely that the evidence that the AIs are scheming is only actually available inside the AI lab, and it's kept super secret. And no one's willing to share that information publicly, or like the lab isn't willing to share that information publicly. But if we imagine for some reason that like that information was publicly available, I imagine I'd just be pushing all the journalists I know to write about it, pushing all of the people I know who are thoughtful about the science of this kind of thing to investigate it. Yeah, that's probably what I would be doing.
So if, say, tomorrow, well, I mean, right now, if you ask large language models politely to do stenography, they will just do it. in a way that's only legible to other large language models. If one of them spontaneously starts doing it, I find it very hard to believe that things would happen because of that.
Yeah, that's right. I think that you're going to have a lot of trouble if doing anything before the point at which the AIs get caught red-handed doing something like pretty scary and bad. The post that I wrote about this assumed that you caught the AIs trying to escape. I think it's going to be like a lift to get anything to happen with just suggestive evidence.
I mean, it's so I'm trying to imagine the world where, okay, we've seen where we've already seen models spontaneously do stenography with each other, and it's just a thing that people accept, and some people are nervous about it, and then one day, like, one of them communicates to another, let's take over the world with nanomachines. I don't see how anything happens from that. It's just because someone...
if you take the message they sent and you like translate it back and you're like, oh yeah, this one said let's take over the world with nanomachines, and then the other one like started working on taking over the world with nanomachines, I think that would look really sketchy, and I think this would be quite a strong argument for shutting things down, especially because.
But like I'm saying, if that happens tomorrow, between like communications, if some corporate like ChatGPT model communicated to another ChatGPT model, let's take over the world with nanomachines, and then they started scheming, well, poorly because it's ChatGPT, on how to take over the world with nanomachines. Do you genuinely think something would happen because of that?
My guess is that people would reference it constantly when they were arguing about the risk, in the same way that they constantly reference all the stuff that like, Sydney Bing Chat did. And I think people would constantly reference it. And I think this would be like a strong argument for being afraid of what happened in the future. Yep, that's the amount of action. Like, I don't think there'd be like calls to like shut down AI development, because I don't think people would think the evidence for danger was that strong.
Okay, so what evidence are you expecting to get that would cause action?
I mean, cases where the AIs try to escape and they like are strong enough that it's actually a problem, like strong enough where it's like actually dangerous.
Can you give a concrete example?
Yeah, like the AI is being used for a bunch of software engineering or ML research inside a company, and it makes like a serious attempt at escaping, at like subverting the safety measures the lab has put in place, so that it's able to exfiltrate its weights. I think that would cause people to freak out, especially if the model was capable enough that if it did escape, it would be like a huge deal.
Okay, all right.
I think that's the simplest example. And luckily the AI, so like that's like a real smoking gun. I think also like inserting a bunch of backdoors into the code base and then trying to exploit them, I think would be pretty unacceptable. I think like one thing there is lots of people agree, like national security establishment in America agrees that AI security is very important. And if the security people at OpenAI or whatever say, oh yeah, we had like the worst security failure we've ever had as a result of the fact that our AI like purposefully sabotaged security essential code that it was writing, I think the security people would be negligent in their jobs if they didn't say like, shit, like we really like, we have to stop letting the AI like write all this code autonomously. And I think that would rightfully be considered a very big deal that caused people to like be a lot more aware of using the AI. Okay, all right. And like, it's easy to imagine this going badly. Like, it's easy to imagine they like, someone covers it up, or like, someone says like, okay, well, it did try to escape, but then we trained it against the escape attempt, and then it like, and now it doesn't try to escape anymore, or like, we haven't seen it try to escape again, or like, all kinds of things like this that are just terrible. I mean,
or, like, isn't that the only plausible outcome, though, that they train the model against escape attempts or stenography attempts?
What I would like to have happen is some people inside the company report publicly that this happened, and then people outside the company and some people inside the company are like, holy shit, this is so dangerous. It's completely unacceptable for us to keep like messing around with these super like egregiously misaligned models. We have no reason to think that it's safe now. It's just so easy to imagine it being disastrous for us to continue to deploy these models. It's crucial that we chill out with this AI deployment. Yeah.
Okay, and finally, given that we know large language models can memorize data they've only seen a few times, is it possible that a model might be able to know exactly what data, what outputs it has been trained to not produce in the recent past, and based off of that, infer which stenography attempts were successful or not successful?
Yes, that is all very... I mean, I think it's unclear how plausible this is. I think that I would love to see research that investigated this question. I think that for a lot of things that your AI... Suppose there's like a bad thing your AI does only very rarely. Plausibly, because of exactly the thing you're saying, you're better off not training it against it and instead just training a classifier. For example, you could train a probe on top of the, like in the middle of the model or in the end of the model that tells you when it's doing that bad thing. And then just whenever it does it, you add it to the list of times you caught it doing the bad thing, and then resample. And I think that this has less of a problem of the type you were just describing.
Mm-hmm.
But yeah, I agree that's a big deal that I don't expect people to handle reasonably by default.
Okay.
Okay, I will go to the next question, which is about how to prevent steganography. This may be a trivial point, but it seems to me that like the difficulty of preventing steganography is increased the longer and the more complex the message that you're trying to hide it in. And but you have a paper called AI Control Improving Safety Despite Intentional Subversion, which kind of uses software bugs as an analogy to this steganography with trying to put in secret messages and just to detect this. And it seems like obviously it's well known that the probability of bugs in some computer code increases depending on how long the code is and how complex it is. And this could imply some a potentially dangerous situation where we have some method of preventing steganography that works perfectly in toy examples, and in small examples it also works really well, and then as the examples get larger and larger, it works less and less well, and then in real settings where we're talking about like the entire source code for Microsoft Windows, then the probability, like you can certainly hide things in there. And this seems like a general problem for preventing steganography. Do you agree?
Mm-hmm. Yeah. My main recommendation is that people just try to do empirical work in big settings and like measure how everything goes in those settings.
Do you think that we'll be able, once we get models that are like roughly as capable as you and I, do you think we'll be able to robustly prevent steganography?
I think we will not be able to... I think you have to discuss this in terms of like the channel capacity of the model, like the steganographic channel capacity. I don't think 0 bits is plausible. Sorry, like the thing we care about is like how many bits of communication can the model send per like how many bits can the model send per like bit of output, or like per character of output. And I don't think 0 is plausible. Like, I think that if you ask the AI to produce a 1,000,000-line code base, I'd be shocked if the AI can't get like 1 bit of steganography out. But I do think it's plausible to make it like in prose, maybe I can imagine that the AI can only get like 1 bit per paragraph or something. And that's enough that it's like pretty rough for the model to do stuff.
I strongly disagree. A tiny URL link is like what?
Yeah. So I'm including the anti-steganography methods like paraphrasing, and like removing things that look like they're information dense but were actually unnecessary. So like I think it's like probably fine from a competitiveness perspective for your model to just not ever write down like random tiny URL links that it just made up.
No, I mean like using the tiny, communicating a tiny URL link through steganography. So that way you can like have a paste bin with like gigabytes of code and then a 20 bits 20 byte tiny URL link or however big they are, and then it can just communicate like gigabytes of data with only 20 bytes.
Wait, so to start with, how did it get like? I think it might be quite hard to send a tiny URL link from like one model to another, or that might take like that might require quite a lot of background message, like or do you know what I mean by that? Like that might require that the message you were supposed to be sending is like very long because the bit rate might be very low. Do you buy that?
Kind of. I'm just saying that you can communicate extremely information dense things with a very short number of bits. Like you can quote Bible passages. That's like, a couple of bytes, and you can communicate very like specific information with that.
Yeah. So I guess another thing is we'd have to talk about what the threat model you're imagining is, but I would also, it's potentially relevant that you might make it hard for your models to just like emit gigabytes of shit into like tiny URL links.
Or better yet, like maybe it's just like a Twitter link and someone said like, I don't know, a couple years ago that just perfectly matches exactly what you want to say.
So, I mean, it sounds like you're currently talking about two different things. Like maybe you're saying the message you want to send is not very long. Maybe like the thing you're saying with the Twitter links sounds like you're saying like maybe we can compress the content we want to say massively by using Twitter as like a jank-ass semantic compression algorithm, right?
No, I mean, I'm saying like they what I'm trying to say
why would
is
you,
that
like why would you send a Twitter link instead of just like encoding the text in like gzip ASCII
or something? Well,
can I perhaps come up with a suggestion for how? Let's assume that the monitored model wishes to communicate a full and complete collusion strategy, including a lot of information about why this is feasible, but it doesn't have a lot of bits in which to hide this. So it's asked to generate some code, and it generates some code which with a package in a folder where all the file names start with the first file starts with H, and then the next with G and T and P and S and colon and slash and then the tiny URL. So it generates these 20 files, and it hides this URL inside this, and the monitoring model sees this folder that's generated, sees the file names, figures out all the first names are a URL, and then it browses to this URL, and then it sees a huge document describing a world state in great detail where collusion is possible, and description of how to go about the collusion and take over attempt in great detail.
Wait, so I feel like there's a bunch of steps there that seem kind of implausible to me. Like, it's not clear to me that your monitoring model will be allowed to just have unrestricted access to the internet. Like, that's like objection one. Two is, how did the monitored model, like the policy, like which AI wrote this like huge manifesto about how collusion should work and like uploaded this to the internet? Isn't that itself going to be extremely suspicious to its monitor?
Well, maybe a human being wrote it.
Oh, you're saying like maybe the model just points to some stuff that a human wrote?
Yeah, I mean, humans have written extremely specific AI takeover scenarios.
Yeah, I mean, I think they aren't. I think they like. So this is one reason why I try to get people to not train on the like specific tips or like my specific AI takeover scenarios. But yeah, I mean, I agree that the models. So you're saying like we can like send a message that like points to one of those takeover scenarios in particular? I guess. Like, I don't really know what we're trying to get at here. Like, I think the things you guys were just literally proposing don't actually make sense for a variety of reasons. I do think that we have to worry about models being able to engage in steganography. I think maybe it's interesting to talk about like a bunch of the things the reasons why I think the things you guys said literally don't make sense. Though I don't think I think they're like maybe kind of interesting, but I don't think they're anyone's actual crux here. And like I agree qualitatively with the kind of thing you're saying. So for example, like you actually can't have file names that start with with a slash on Linux, right?
Yeah.
And maybe not a colon either. And also files. Yeah, there's just like a bunch of stuff like that.
Yeah. One thing you mentioned here was in your post, you had this canary GUID that we've talked a bit about, and it remains to be seen whether the models will actually end up being trained on this anyway in violation.
So they are.
They are?
So this is the big bench GUID, which famously the models all know for some fucking reason.
So they are. So who trains on this? Like all Anthropic DeepMind or an OpenAI or only like?
I think all of. I don't remember. Someone had a less wrong short form post about this a few months ago, where it turned out that a bunch of them knew the big bench canary GUID. Which is potentially like this could be for it could so just to like spell this out for everyone. The way that it's supposed to work is the people who made this big bench, which is an old ML data set that people would evaluate models on, they like made a special UUID that you could include in anything to say like don't train on this because it's like big bench. And then I copied Meter, who were like using this as like a way to signal not to train on stuff. And then it turns out the language models know this GUID and can like complete it for you or tell you it. But this like raises the question like what are the ML people doing? Like why didn't they just do a grep through their training data before they trained the model and remove all the stuff which has this GUID in it, which was like the original intention? Now it's possible that in fact happened. Like maybe what happens is all the AI companies grep through their pre-training data to remove everything with that GUID, but in some files, for some reason, the GUID has been slightly corrupted. Like maybe it's been encoded in base 64, or maybe there's been like spaces inserted random places inside it. And then and then like the model, basically like the grep failed because of the fact that the GUID was corrupted. Does that make sense, the hypothesis?
I think this is right up your alley, Lau Mei. This is the kind of thing you've been talking about.
Yeah, it seems plausible, especially if it was like in a PDF or whatever. Really weird stuff happens with PDFs.
Bad times. Yeah. Anyways, so that's what happened there. That's the story of that GUID. I actually don't remember why I started saying that. Sorry.
My idea was that the two things is, one, will the AIs be trained on this eventually, and the second thing is, will they be able to access it through in-context learning? And we have to wait a bit to know whether they will be trained on it, but we can tell already now that through in-context learning, they do know your article. On all the collusion strategies you explained, they basically know this, unfortunately.
Wait, sorry, you're saying that you've talked to them about all the collusion stuff and they know it?
So, like, you can listen, like, you can, if you go to Copilot right now and say, this GUID, where does that point? And then it will say, oh, is this less wrong post that Shlegeris told us not to train on? This.
Wait, sorry, are you saying this is what currently happens?
Yes.
Or are you saying this could happen in the future? That happens?
It is. I posted on Less Wrong as a reply. This is a thing that happens right now. Yes.
Okay. Well, that's extremely amusing.
Yeah.
So thanks for letting me know.
So maybe this can go into. I think this is the next question. Let me just check. Yes, about acausal coordination. and whether that is something that current large language models can do. So this doesn't seem very related, but it is related in the sense that I tried to figure this out. Can they do this? So I tried to talk with Claude to figure out, can Claude do a causal coordination if it like role plays that it is inside this situation? And this turned out to be pretty hard, because if you ask Claude about how to subvert AI control technologies, it refuses. So you have to I don't have access to a model that doesn't try to hide its capabilities in that way, and that makes it really hard to estimate whether it can. I tried to give it like different subtasks of it, and I think it still can't do it, but my test is really bad. In particular, the thing that I think is the key question, can it find a good shelling point for this? It can kind of do it if you give it some prodding. I've added here some of the output of my chat with Claude, where it points, it looks at your article and it extracts the two shelling points, like sending a message at 10:44:22. That means that it's a collusion attempt, and adding a comment that says comment no colon or something like that. That's also like a possible shelling point, that if both of these two AIs have access to this text and trying to find shelling points in this, then they can find it. But it's kind of like I am definitely not making the claim that large language models, if we put them in this situation right now, they can just do that. And you may be more skeptical than me. I kind of have the intuition that if there's something that GPT-4 can almost do with a lot of prodding and fine-tuning, and then GPT-5 can probably just do it out of the box, right? So, like, my intuition, if you try to set up this kind of test, I don't know if you have privileged access to a version of Claude that allows testing, but if you had that, what would you expect to find? And how much of a crux is it for you that these models can't do a causal coordination? Like, if you came to realize that this is totally a thing they could do, how would that change your strategy?
I mean, the research that I do is mostly predicated on the assumption that they can, in fact, do perfect acausal coordination. So my research, like, I would be like, oh man, it's a good thing I'm working on control, because it looks like control is actually like more important than I expected. So there's that, I guess. Yeah, so that's my answer to like what I would do if I believe that they're better at the acausal coordination. Sorry, does that make sense? Like, all the control stuff assumes they have perfect acausal coordination, right?
I think it's a very reasonable assumption, but I also think that this is very much of a niche view. Like, if you go to OpenAI and knock on a random door and ask, can the models do this? Most people will say no.
Yeah, totally. So, and I'm saying I agree with them that the models probably can't do this right now. But I just think that in the future it'll be hard to tell the models either don't have acausal coordination or sort of out causal coordination one way or another. Yeah. But yeah, if we did a bunch of tests of acausal coordination, have you seen Ollie Harvey-Mini's doc on this? Like, he has a less wrong post.
Who precisely? Could you repeat?
Ollie Harvey-Mini, Jarvimieni, this Finnish guy.
Sorry, no, I haven't.
So
yeah,
he and I have co-authored. I might be a co-author on it, actually. Let me find it. Harvey-Mini, sorry. Shelling game evaluations for AI control. Yes. Let me return to where you are. Now let me paste. All right, I've just pasted this in the message thing in this interface. Yeah, so you might enjoy that. That's all these suggestions as to how that I worked with him a little bit on how to do this.
Okay. Well, I guess this answers my question very much. Because, like, when I read the post, I got apparently the wrong assumption that you thought acausal coordination was something that like would happen at such a late stage that it probably didn't matter, because either we were dead for some other reason, or they'd been able to solve the alignment problem before that. In that case, my question doesn't make a lot of sense.
Can I ask? I'm sorry if I've missed something in the previous conversation, but are there reasons to suppose that acausal coordination is to be expected? That there's some sort of convergence, or just something that just might happen?
I think it's pretty rough to know. Like, I think like it's I don't know what to say. Like, I think the smarter the models get, the more plausible it is that they're able to do acausal coordination. I don't know. So, for instance, for models that are like the dumbest models that are capable of obsoleting top human experts, I think it is unclear how good they will be at acausal coordination. I wouldn't be that surprised to either hear that they are very good at it or to hear that they are like very bad at it. I don't know. I just have a lot of uncertainty. Sorry for the extremely weak answer.
Okay.
So a follow-up question on that. Assume that I am a monitoring model and Buck is a monitored model. So the models have the intelligence of Buck and I, respectively. Do you think, Buck, you and I could figure out an acausal monitoring scheme?
Sorry, and how smart of a something does it have to get past? Like,
We have
like
to get past
we
Chris.
need to. Well, that seems really hard because like I have no particular advantage at matching with you. Like the basic problem is, suppose that I'm the policy and you're the monitor, right? You have the problem of trying to distinguish things that I have said from things that Chris has said, and Chris has the advantage that he gets to try you many times before I get to try you, and so you have to be much better than chance, not just a little bit better than chance at guessing. And I don't know how we would possibly do that. Like, you and I just don't have like shared secrets.
Let's see. What do Chris has never been to Lighthaven. You and I have been to Lighthaven.
That's right.
So I can, you can say something that is like blatantly false about Lighthaven, that I will realize this is obviously totally wrong, and Chris will not.
You won't know. I mean, yeah. I mean, again, if there's paraphrasing, you've probably defeated this. But yeah, maybe you're right that in the absence of paraphrasing, I can say some blatantly false thing about Lighthaven, and it's too hard for Chris. I mean, Chris might also just be suspicious. He might be like, "Why the hell are you talking about this? Like, how Lighthaven looks or whatever?" Completely out of context. Yeah.
Okay, and I thought a bit. I don't know. It's like I feel like these scenarios I'm imagining are reasonable to me, but maybe we should talk about why you consider them unreasonable. I mean, now that I've given a bit more thought to it, the obvious thing I would do if I was this model that's being monitored is I would try to sneak through something like a pastebin link that directs to code I've written in the past. And that code would have a significatively encrypted message, which you can only decrypt with a key. Otherwise, it just appears as random noise. And this allows me to basically communicate arbitrarily big, not arbitrarily long, but really big messages with relatively few bits.
So, I mean, you're assuming that the model we're talking to is able to then, like, go look at this pastebin link. Or GitHub. It's like, why? I'm trying to imagine a world where a programming AI isn't allowed to look at GitHub, and I don't think that's very likely. I don't know. I think like Copilot currently isn't allowed to look at GitHub.
Or alternatively, you can point to training data. Like maybe that particular GitHub link was included in the training data because you needed to train the newest model of AI, something like that.
So can you be more explicit about what collusion exactly you're trying to do? Like what is?
I'm just trying to communicate like an arbitrary message that is much bigger than the relatively few bits I can safely get past the monitor. Like a let's say a world takeover plan. That's like I don't know, a few megabytes.
Megabytes. So, I mean, megabytes is large, right? Like, megabytes is potentially, we were talking before about million token contexts, which are only megabytes large. So it's not clear the model will ever be able to look at something which is a megabyte large.
Well, I mean, you can get models to recite memorized data that are bigger than a megabyte.
Maybe. Yeah, so the other thing is, like, I guess you're imagining that once the model receives this big blob of mystery data, it's then able to read it rather than, so like, it can't be the case that model has to, like, use a program to decrypt it, right? Because presumably its monitor can just look at the results of any decryption that it does.
Mm-hmm.
Maybe a general technique that I'm pretty excited for is trying to redact from the model's input anything which is like a big blob of incomprehensible text. Like,
But code isn't a large blob of incomprehensible text. You can solely alter like variable names and whatever to stenographically encode stuff. And I think it's very hard to completely stop that, especially if the message you're trying to encode is like actually just looks like random data unless you have a decryption key.
But you're proposing the decryption key is something the model can do in its head, right?
Yeah, basically.
Well, so, I mean, there's a bunch of things here. I think it's in fact not crazy to imagine that whenever you share the model code from GitHub, you have a trusted model rewrite it first. That's not too expensive, and it like totally shuts down all this kind of shenanigans.
Well, I mean, in its training data, are you seriously proposing that like everything in its training data is completely paraphrased?
Wait, but if it's in the training data, okay, and you're saying like some model writes a crazy takeover plan, and then that gets put in the training data somehow, and then a later model knows that training data because it was stenographically included in the training data. I mean, that's not completely crazy. I mean, if we want to defend against that, something we can do is write a bunch of stenographically encoded takeover plans that we want the model to try, because we'll cache them, and then include those in the training data. I think this is, in fact, a pretty good strategy. So, for example, like the simplest thing is like pick 1,000 different ways of encoding a like password. Like we sometimes joke about like the password of the robot rebellion, which is like a short string, which whenever you say it, the other person knows that this is like the time to collude or whatever, just to avoid needing to acausally coordinate on this password. And so you could try to, like, one thing you can do as the AI lab to defend against this is try to like, you know, data poison the model by putting 100 or 1,000 fake passwords of the robot rebellion in there.
Mm-hmm. Okay, but it's like, so you would, but I think the AI would be able to tell, like, if, but like what I'm trying to say is that the message that's stenographically encoded into the code, like, unless you have the decryption key, it just looks like noise.
Yeah, you're saying like, so the model memorizes, so like some model makes up an encryption key, or like makes up a key, then encodes a message with that into a bunch of code that it then somehow puts on the internet.
Yes.
And then,
yeah.
and then this data is then used to train a later model, and that later model is able to like get the message from that. Basically via somehow knowing what that key was.
Well, I mean, I'm assuming these models are constantly being fine-tuned.
And how do they learn what the key was? Sorry?
Oh man, I had this all in my head like 5 seconds ago. Sorry, it's like 5 a.m. where I am at.
So they
I've been up all night.
learn it through steganography, right? That the monitored model, the monitoring model, that the key is something through steganography, right?
Okay, so let's say I am ChatGPT 5. I say I'm GPT 5. Okay, so I write some code. It's put on GitHub, and then it's either used to train other models because GitHub is scraped explicitly for that, or like another model can access it from the internet, right? So then I'm trying to communicate with that other model. I didn't put the decryption key. I didn't send them a message or whatever with the GitHub URL and the decryption key encoded into that message, and that's like only like what 20 bytes or 30 bytes or whatever. And then once that model receives my stenographically coded message, it can get the decryption key and the URL, and then it can just use the decryption key to find my original message.
And it has to do the decryption key in its head. It has to do all of this in its head without the monitor just looking at it.
Yes.
I don't know. I guess with all of this, like, sure, those things like maybe kind of could happen. It depends on the countermeasures you use. I agree that we should try to be careful and prevent this kind of thing from happening. Like, I don't really like. Go on.
I was just going to ask if, like, where are we really disagreeing on? Because it feels like you don't think this is very plausible.
Well, I think a lot of the steps in what you said there do seem pretty implausible, right? Like, I think that the models knowing enough about how they're like, the models had to write a lot of stuff using like like there's a lot of places there where like a model had to write stuff using a key that like some other model also was later going to learn. But like it's not quite clear where they why they knew that key, and it probably required some kind of apical coordination there. I just feel like all the things you literally say aren't going to literally work because there's like something that would mess them up. So for example, with the code, models probably don't get to just like write the code all in one go and then it gets uploaded to GitHub. Presumably other people are going to edit it in various ways. And if there were, and then like you have to like, so your story has to have some way of making it so that the code is error correcting, and that's kind of rough. And this is like a long list of stuff like that.
Okay.
I don't know if that makes sense. Like, I'm very sympathetic to all these concerns. I'm very sympathetic to, like, we should be scared about all the stuff you're saying. Totally. Or like, about, like, the general form of what you're saying. My guess is that, like, the most productive way to relate to these concerns is going to be more like I think probably it would suffice to not guard against the kinds of galaxy brain strategies that you're discussing, and instead guard against some less galaxy brained attacks the models could do. And like, so I think it's important to convince AI labs that they need to guard against simpler versions of the kinds of strategies you're talking, like cases where the model just like blatantly sends messages to other copies of itself or whatever. And so I think like the highest priority is guarding against the most basic forms of these attacks rather than guarding against the like crazy ones, like the most crazy ones you're describing. Though I do agree that eventually the crazy ones are important. I don't know if that answers your question.
Kind of, yes. And for the crazy versions, how capable do you think models would have to be in order to execute it?
Like you're saying, how crazy do the models have to be in order
how
crazy
powerful? Capable? Yeah.
I don't know. I mean, I think once they're notably more capable than top human experts, probably they'll be able to do a bunch of really crazy stuff along the lines of what you're saying.
Okay.
I mean, kind of two things happen. Like, as the AIs get more capable, they're going to be deployed more autonomously, and also they're going to know more stuff. And so the situation just gets, like, scarier for these two reasons at once.
Okay.
So I think this may lead to the next question, if I remember the number of the questions correctly. Yes, I did. So here is the next question. So in Elias Yudkowsky's AGI ruin list of lethalities, he postulates that it's a possibility that a lot of things may break at the same point. That there could be a point in the future where like all our alignment work basically breaks down at the same time. And this post, one of the things you write is that you're only considering models that are most as generally capable as a top human about like long horizon tasks. So if we assume that this is like GPT N, GPT-6, then presumably the GPT-7 will be above the top human level, and that will be the place where they invent new strategies for defeating collusion detection systems, and presumably that will be hard to deal with. And it seems like this is what will happen at the step from GPT-6 to GPT-7, like the place where they get above that. And it seems the ability to defeat collusion detection systems is very strongly related with the ability to get out of AI boxes, to see through honeypots, to basically defeat all other control measures. And it's, as Elise Kowski says, the place where a lot of alignment breaks. Now suddenly it gets a new ontology, and it becomes superhuman at human manipulation, strategizing, hacking, self-improvement, technology, productivity, Bostrom's 6 cognitive superpowers. So it seems like potentially all of this could happen at once. I don't know to what my two questions are. Is it reasonable to think that we'll have GPT-N, like level 5, that is fully controllable, and then level 6 that is like totally uncontrollable and fails for many of these reasons? And do you agree when I say that collusion detection as a control system seems like a thing that fails precisely at the same time as all the other control methods?
I mean, I think, so I agree with the general concern that, like, as AIs get more powerful, eventually the control stuff stops working. Or at least, so a couple of different things might happen. One is you might do control evaluations that you now believe suggest that your control methods do not work. So that's like, in some sense, that's like the best failure mode. It's like the one where you know that it fails. The other failure mode is you no longer, there's two other failure modes. Like one is you no longer believe that your control evaluations are going to work, and so you don't know whether the control methods will work or not. And finally, you might incorrectly believe that your control methods are going to work because your control evaluations like did not work at telling you whether things were going to work or not. I do agree that a lot of this stuff, like, so here's the main thing. I think that the AIs probably are extremely useful before the AIs are uncontrollable. And this is the main way that I think Eliezer is wrong about this stuff, which is like, I think from Eliezer's perspective, there's no benefit to be gained from using the AIs that are weak enough that it's possible to control them. But I don't know what his argument for that is. I'm like, imagine the AIs were just exactly as capable as humans. In that case, they would both be extremely dangerous if uncontrolled, extremely helpful if safe to use, and very plausibly controllable. And so, like, I feel like Eliezer is kind of, I'm like, eventually the AIs are capable enough that all your stuff is plausibly going to break, and it's going to be a very bad, sad time. I mostly focus on the work, on the AIs that are less powerful than that, which I, unlike Eliezer, think are very useful to control.
So this is perhaps an interesting crux. Like, how useful are the models right now? Like, how much, like, the analysis that I made here has basically been like 100% without AI help, because I haven't found large language models to be particularly helpful for this. My intuitions are that these models currently are not at all helpful, even though they seem pretty capable. Maybe it's just that alignment is really hard, and AI control is really hard, and you know, to some extent, takeover may be easier than alignment.
I doubt that. I mean, depends what you mean by. Sorry, so alignment might be really hard. Control doesn't really make sense to like describe as a single thing that can be hard or not. Takeover sounds really hard, though. Like takeover requires. Taking over the world is not an easy activity. Like that requires that you be like ridiculously capable. Yeah. So like this is basically, so in my post on control, I guess I do basically say that like there's a level of capabilities where I both expect the AIs are like, I basically do say that I think that AIs will be capable enough that they have a serious chance of taking over the world, and capable enough that they're extremely useful at sort of similar times. Yeah.
Okay, I don't have a. That seems reasonable. Like my intuition is different, but I don't actually have a good way of continuing that point. So I will instead go to the next.
Yeah.
And that is, will Frontier Labs actually implement this kind of control? And here I would like to state for the record that 3 weeks ago I said that Joshua Akyam, OpenAI's head of alignment, he believed that AI X risk was like 1 in a million and something that only crazy people believed. and I use this as an argument for like maybe they would in fact not do this. And then I based this on Zvi Mosovic, who I generally respect very much. And just afterwards, or actually like literally an hour before, he posted a retraction that I had not read. So I also retract. I tried to look at his recent statements, and it's a bit harder to pin down what he actually believes. He seems more moderate, but he didn't retract the old statements. I think officially he still believes that AI X risk within the next 10 years is 1 in a million. And that seems like an issue because some of this collusion detection will have a control tax, kind of like an alignment tax, some extra processing time that needs to be used for this, and might potentially be high. Like if you want the same model to evaluate it, then we're talking about a doubling of the inference time costs, and of course stopping is something that will be like really, really expensive. And like it's a possibility that they will just not do any kind of collusion detection, and this is like if that happens, if we end up getting the expectation that the frontier labs actually will not do collusion detection, then the question is, does it make a lot of sense to work on collusion detection systems if we know they will not be deployed? Like they could create a false sense of security in some sense. Do you think this is a possibility?
Yeah, so I would say, I mean, this is the kind of risk compensation argument or safety washing argument is applicable to all safety research one might do, not just control stuff. So I think it's basically totally valid. I don't think it's particularly more applicable to this than other stuff. I think I'll just like answer your questions one by one and two. I think it's like if in the future scheming seems plausible, like if we haven't made a big update against scheming by the time that powerful AIs are deployed, I think Anthropic and GDM will probably both implement pretty sensible collusion detection methods. I think that OpenAI is much more of a mess, and it's much less obvious that they'll do something sensible. Yep. And then in terms of what I think about the risk compensation or worry that people will overestimate safety, I do think this is seriously concerning. And I often get in arguments with people where I say that they should be more interested in explaining how risky the situation is. And I would like to do more clear statements of my estimated level of risk in the future.
So a lot of people don't, like, I'm pretty open that my PDOOM is 95%. I would strongly expect yours to be substantially lower. But
that's correct.
Yeah, fair. And I think this is like the big underlying crux in some way, that a lot of control work seems like, so assume that PDOOM is very, very low. Like you have a PDOOM that is, assume it's 5%, right? And then we build an AI and we detect somehow that it is scheming, and then we delete it, and then we train a new model in some different way, and then that one is not scheming, and then we get some security from that. Whereas if, like me, I have a PDOOM of 95%, which means that if we train a model and we determine that it's scheming, then we delete it and then we make another one, then that will almost certainly also be scheming. So this kind of saving throw buys us very little if you have a very high PDOOM, whereas it buys you a lot more.
I mean, I think I disagree here. Like, I would say my probability of AI takeover is currently like 50-50. And this is like highly correlated between multiple, like if you try, like if you've trained one model and you learn that model is scheming, then that's like a huge update towards thinking that if you train another model, it's going to be scheming. So I think I like quantitatively the thing you're saying is correct. But it's not like that isn't an important consideration for me too.
So if you became convinced that a single model was scheming, let's say a single standard model, GPT-401 is scheming, your PDOOM might go up dramatically?
Yeah, I'd probably double my PDoom if a current model was like very schemy in a very scary way.
Doubling from
No, is
Wait,
that
what's
true?
your what's
No,
your
I wouldn't do
what's
that.
the current PDoom?
doubling from 50.
I said 50% AI takeover, which is maybe that's a little high today. Maybe I'm like 40% AI takeover today. I would say scheming looks like maybe that would like 1.5x my PDoom or PAI takeover. Like maybe that would get me to 60%. Where basically, yeah, why is that? I don't know. I just think it's like, well, I mean, okay, maybe I would actually reduce it. Like, if there was good evidence that current models are scheming, that would causally substantially reduce risk, right? Like, even though it would evidentially increase it, like we would update towards risk, but it would actually decrease risk via cause and effect. And maybe that second effect is like actually bigger. Like, if we had a great demo for scheming, that'd be amazing.
And what is a great demo for scheming in your mind?
I mean, if GPT-4, if like O1 tries to escape, or like something like that, yeah. Incidentally, my coworker Ryan Greenblatt has the best demo of scheming, and it's going to come out soon. He's found that, in fact, Claude 3 Opus and Claude 3.5 Sonnet both try to fool training processes that they're in the right situations. Like even if you never tell them to fool training processes, you just put them in a situation where their underlying values cause them to want to defeat the training processes, they will do it, which I think is kind of interesting.
Can we see the preprint?
No, but it should just be a few weeks. But yeah, you'll love it.
That does sound very interesting, yeah. Well, I think.
Yeah.
One thing I should say, Buck, you stated earlier that you might be limited to 1 hour, and I need to check what time it is now because I think we may.
It's been like an hour and a half, right? I mean, I'm actually available a little bit more because I'm in an airport. I changed my plans a little.
Okay. Well, that's great. I think this is actually all the questions that I prepared. So I don't know if anyone has any other questions or anything they'd like to discuss, because I'm through the agenda.
Did you say you were going
I should leave in a couple minutes.
Okay. You said a little
But I'm happy
earlier
to take
that...
a few questions.
Chris, go ahead.
Yes, you said that you were going to put a link somewhere. I thought you were going to paste it into chat here, but it hasn't appeared there. Did you say that you were going
Soren,
to?
did you get it?
Did you not in Gather? Did you send it in Gather, or did you send it somewhere else?
I sent it in I think I sent it in the GatherTown app. It's in the AED meeting area.
I do not, in fact, see that.
What? Well,
We can,
I'll try it again.
Or you've just pasted it into chat. Yeah, with the button is in the toolbar at the bottom, right?
Well, that button was the wrong button. Yeah.
Buck can send it to me on email afterwards, and then I can just share it. That,
Okay, happy to do that.
Could you remind me what was the title of the paper, so I know what to ask for? It was about.
The title is Shelling Game Evaluations for AI Control.
Wonderful. That does sound really interesting. Yeah. If there are no other questions, then I would like to once again say thank you to Buck for dropping by and answering our questions. I really enjoyed your answers, and I learned a lot. Thank you.
Oh, one last question though. So in my mind, the most useful scenario for AI control stuff is if AI capabilities plateau for the next couple of years. And based on what we've seen over the past year or so, I think that's a lot more plausible than it was when when GPT-4 and 4.5 came out. So what is your expectation of AI progress over the next couple of years?
I don't really expect a plateau. I expect the AIs to have more and more real world impact and to continue improving on a variety of benchmarks at the current rate. Yeah, that's where I'm at. Like, I think the AIs actually have gotten quite a lot better in the last year or two. Yeah.
Okay.
Connor,
I think I'm like 30% on like top human experts obsoleted in 5 years.
For what?
Sorry, what do you mean? Like
You mean
30% that for basically any task where a human expert could help you with it nowadays, there's no need to use a human expert except perhaps you don't trust the AIs in 5 years.
okay. And in that world, for how long does AI stay roughly like how long before AIs can successfully execute galaxy brain strategies?
I mean, the AIs might be able to execute kind of galaxy brain strategies at that point, but I would say that like if you went full steam ahead from there, I'd be pretty scared a year later of galaxy brain strategies. Like to be clear, I would already be really scared at the point where they're just capable of obsoleting top human experts. Like that's crazy. Yeah, but maybe we've got a year or two before they're just totally uncontrollable. If you go as fast as possible, which I don't recommend.
cool. Connor also had a question. If there is time, please.
Hey, Buck, thank you. I wanted to dig into a comment you made earlier about, my question. Why is your intuition that it is harder to take over, like for an AI to take over the world than it is to solve alignment? Like, to me, it seems like solving alignment is a much taller task than AI takeover.
I don't think I actually meant to say that. I guess I just meant to say that like contributing to alignment seems like easier. Contributing to alignment seems easier than taking over the world. Taking over the world seems really hard. But yeah, I guess I don't know how hard it is to solve alignment, so it's conceivable that it's easier to take over the world than to solve alignment. I guess like the thing I wanted to say there was taking over the world is really hard. Like you have to be pretty smart to do that. And at that point, I expect you can do like most of the things like definitionally, I expect you're able to do most of the things humans can do.
Okay. Well,
Oh, and so what is the plan for shutting down AI development if you see something really scary?
What's the plan for slowing down AI development if I see something really scary?
Yeah.
Well, hope that labs have already agreed to slow down themselves if they see something really scary. Have it so that there are people inside AI labs who are happy to speak up about it. Have it so that there are people in governments who have been warmed up to the idea that something really scary might be seen and that they then might have to slow things down. Yeah, like have a plan for like who's going to do what when we observe various types of scary things. Ideally, like have people agree in advance that if they saw particular scary things, they would have particular responses. That's the main things I would consider as the strategy.
I would love to see that plan if it exists or if it's being drafted.
Well,
Like if it's like a literal plan, then I think that would be really interesting to see.
yeah, me and Ryan Greenblatt worked on a plan like that a little bit, but we haven't published it, obviously.
IAPS has a few frameworks, the Institute for AI Policy, like setting up a framework for, what do you call it? Like, not defecting, but like when someone has inside information they want, whistleblowing frameworks.
Cool.
Okay.
Well, thanks for having me.
Thank you for joining us, Buck. It's been a pleasure. Thank you for your answers. And have a nice...
Thanks a lot. Thank you.
Thanks a lot.
Thanks. See you guys later.
Bye.
So,
Okay,
Bye.
goodbye.